Hello, this is a quick lesson about topographic maps. Learning objectives include interpret the steepness and shape of slopes using contour lines, use contour lines to determine elevations and the relief between locations, use contour lines to identify erosional and depositional landforms. There are many different types of maps, some of which I'm sure you're familiar with, such as a political map that shows the borders between countries and their major cities and capitals. Here's a map showing different climate regions of North America, hence climate map is the name. And I would guess you've all seen a map like this that shows the streets and freeways in a city like Los Angeles. This map looks different than the previous three in that it contains all these brown curving lines with numbers attached to them. Those are the contour lines that are the defining characteristic for a topographic map. So contour lines are the definitive characteristic of topographic maps. These allow the viewer to interpret the elevation, slope, and shape of the landscape. Every fifth contour line is an index contour, which is used to index or indicate the elevation along that contour line, and is indicated with a thicker, more heavily weighted line. The contour interval is the amount in feet of elevation gain or loss from one contour line to another. This amount is consistent throughout the map. For this map here, the contour interval is 40 feet per line. This map shows contour lines become increasingly more closely spaced as we go from west to east across the map. This indicates that the slopes are least steep in the west and get progressively steeper as we go to the east, with the steepest slopes here, or most closely spaced contour lines, indicating the mountain front. A unique type of contour line is called a Hatchard contour line. Let's zoom in on that. So the contour line has these little tick marks on it, and that indicates a closed depression. A crater at the top of a volcano would be an example of a closed depression. Let's check our understanding of interpreting the shape of landforms using the shape and spacing of the contour lines on the left and connecting that to what the landform may look like in profile or cross-section view. I'll give you a moment to think about this. So 1 would connect best to B, 2 would connect best to E, 3, D, 4, C, 5, F, and A connects best to 6. Map scale. Map scale indicates how distances on the map relate to distances in real life. A map with a fractional scale of 1 to 250,000, for example, means 1 unit of measure on the map, say an inch, is equal to 250,000 of that same unit in real life. Smaller scale maps, like 1 to 250,000, show more area, but in less detail in comparison to larger scale maps, which show more detail, but less area. So here's Maytown on the smaller scale map. All we see is just a little dot indicating where it is, but a lot more land area around it. And then on a larger scale map, we've zoomed in and we have a detail of Maytown, but little area shown around it. Graphic or bar scales are always included on topographic maps, and they make measuring distances on the map easy in miles, feet, or kilometers. That's it for now. You're going to learn more about this stuff by working through the laboratory exercises and readings in your textbook.